Okay, so here we go. La racine carrée des carrés parfaits. Square root of perfect squares. So the first question in here says, write the 21st perfect squares. All right, so here we go. The first 20 perfect squares. So the first perfect square is 1, because 1 times 1 is 1. 1 squared is 1. After that, we have 2 squared, which is 4. 3 squared, 9. 4 squared is 16. And so on, 25, 36, 49, 64, 81, and 100. So those are the first 10, and the next 10, which is 11 squared, 121, 144, 169, 169, 196, 225, 256, 289, 324, 361, 361, and 400. Now, if you ever forget one of these perfect squares and you're looking to identify one of them, you can always use the area model, which is basically just doing, let's say we want to do 17. This one here, a lot of kids forget that it's 289. Well, you would do 10 and 7, which is 17, and multiplied, here we're multiplying by 10 and 7 again, and you would just do your area model. Now, we know that 10 times 10 is 100, and 7 groups of 10, which is 70, 7 times 10, and again 70 here, and 7 squared is here, so 49. And then you just add all four numbers, so you have 100 plus 140, which is 240, 240, and then plus 49 gives you 289. So if you ever forget one of these perfect squares, you can use this method. Now, let's move on to a couple of examples. First example, it says, calculate the number that the square root is. So this is a square root. I want to find what perfect square that this is a square root of. Well, we simply multiply it by itself. And we've seen how to multiply fractions. You multiply your numerator by your numerator, denominator by denominator. So that means that 3, you have 3 times 3, which is 9, and 8 times 8, which is 64. So what does this mean? It means that the square root of 9 over 64 is equal to 3/8. Same thing here. Now here we have a decimal. You could multiply 1 and 8 tenths by 1 and 8 tenths. However, if you take this and you transform it to a fraction, which is 18 tenths, and multiply it by 18 tenths, it's a lot easier because we have the perfect square of 18 squared, which is 324, and 10 times 10 is 100. So you leave it at that, or you could change it to 3 and 24 hundredths, $3.24. So what does this mean? It means that the square root of 3 and 24 hundredths is equal to 1 and 8 tenths. There we go. This is how you find a perfect square from a root. You multiply by itself. Example 2. So it asks, these fractions, are they perfect squares? So if they're perfect squares, they will have a root. Now looking at this first one, you would say no. However, this is equal to 4 over 9. 4 is a perfect square, 9 is a perfect square. Hence, the square root of 4 over 9 is equal to 2/3, which is the root of 8 over 18, meaning that this, yes, it is a perfect square. And then look at this one here. 16 is a perfect square by itself. However, 5 is a prime number. A prime number the only prime number that is, well, 1 is not a prime number, so all prime numbers are not perfect squares. So this one right here, no. So this one here is not a perfect square. Same here, 9, yes, by itself is a perfect square, but 2, no. Both have to be a perfect square. Both have to be a perfect square so that the whole fraction is a perfect square. So this one, no. And finally, our last example. Are these numbers perfect squares? So we have fractions here, now we have decimals. So to identify if it's a perfect square, yes or no, you put it as a fraction. So this is 2 and 2500, or 225 hundredths. Now let's look at this. Is this a perfect square? Yes, it is. Is this a perfect square? Yes, they're both perfect squares, meaning that the square root of 225 over 100 is equal to the square root of 225, which is 15, and the square root of 100, which is 10, which could also be written as 1 and 5/10. And our final example for today, again, you would have to identify if this is a perfect square. Well, this is equal to 225 thousandths. Now this, yes, it's a perfect square, but this one, no. Like I said earlier, both have to be a perfect square so that it to be a perfect square. So this one, I would have to say it is not a perfect square because it does not have a root. There we go. Here are your suggested practice problem in the book. Happy practice. Don't forget to check your work at the behind the book.